Hello everybody. Today's topic is why traditional VLAN segmentation isn't enough to prevent zero-day exploits in your network. I'm going to show you a quick demonstration video to prove this point. So we're going to start out by looking at an overall topology of the demo that I'm going to present, and we're going to start with just a pfSense firewall separating two networks. And on the one network is a web server that is vulnerable for log4j. And on the other network, a Windows 10 user endpoint machine. We'll begin the demonstration with a firewall policy that only allows this one Windows 10 desktop to talk to this one web server on port 8080. By some standards, we would think this is a great security design, with the least privilege access being given between two machines across a network. But as we will soon see, this segmentation design is not enough to prevent an exploit like log4j simply by filtering on source, destination, and port, and that we need deep packet inspection and a next-gen firewall capable of looking further into this traffic to prevent this type of exploit. So right now, let's hop over to our live demo, where we will start with a sample web application loaded from the Windows 10 desktop. So here we are in our Windows 10 desktop with our sample application loaded. As you can see, this looks like just a basic web form with a typical login screen. But on the back end, we have our attacker PC who is firing up NCAT and going to start listening on port 9001. And we'll see how this comes into play in just a moment. So back in our web app, to show that this does function like a normal web page, we can log in with a set of credentials and see that we get a successful login screen. So the web app behaves and works normally. But what happens if the user gets tricked into clicking a link that hijacks this session and possibly inserts malicious code into the username field? For this example, we'll insert some malicious log4j code into the username field and click the login button. To the user, it looks like nothing out of the ordinary is happening. However, over on the attacker machine, we'll see that a remote connection has just spun up. Let's run a few shell commands to prove that we are on the web server. Running whoami, we see that we are logged in as root to this machine. If we fire up pwd, we'll see that we are sitting inside the Tomcat directory on the web server, and we can run ls to list out the files sitting on the machine. From here, we could run much more destructive commands to begin modifying, removing, or altering the contents of the web server. Back over on our end user machine, we can see the login event completes with an error indicating the password was invalid, but no indication that anything malicious was done on the back end. And now, with the help of time shifting and the magic of virtualization, we're going to rip that pfSense firewall out, and we're going to drop a checkpoint firewall in its place. This firewall will leverage the same topology as the pfSense firewall did, the difference, of course, being that we will leverage next-generation threat prevention that is able to look deeper than just Layer 3 and Layer 4 filtering and access controls. A quick review of our checkpoint policy demonstrates that it is the same as the one used in the pfSense firewall. The difference here is that we will utilize Checkpoint's autonomous threat prevention policy, which ensures your protections are continuously up to date with the latest prevention technologies, ensuring we are protected against log4j exploits. In fact, we can drill down into these protections to see that there are a number of signatures included to prevent log4j exploitation. Now, with our checkpoint firewall in place, let's go back to our web app. We'll use the same injection in the username field as in the previous example. However, when we click the login button, we will see very different behavior. This time, instead of seeing a password error, we see a connection was reset page, indicating that the form submission never completed. If we go back and look at the checkpoint logs, we will see that there were a number of different events that occurred on this user session. We see an IPS event, and when we drill into the details, we're able to note that our firewall caught the log4j exploit being attempted and prevented it. We can also see the autonomous threat prevention policy was responsible for the prevention, and down in forensics details, we can see the details of the URL that was involved in the attempted compromise. Finally, back over on the attacker machine, we see that we are still listening, but no successful connections have been made, thus illustrating the exploit was not successful. I hope you found this brief demonstration helpful in understanding why traditional VLAN segmentation without deep packet inspection is just not enough to prevent active zero-day exploits on your network. Whether these VLANs are simply routed through a switch or router, or are filtered using layer 3 and layer 4 access rules, exploits can still slip through. At Checkpoint, prevention is our key philosophy. Detection just isn't good enough. If you have any questions or would like more information about how Checkpoint can help you stop zero-day threats in your environments, please reach out to your local Checkpoint account team or find us on LinkedIn. Thank you.